Hello and welcome to all our participants. My name is Akash. I'll be your host and speaker for today's webinar, Blockchain on AWS for Businesses. I have with me Mr. Himanshu Malavya. I have 6 years of experience in leading digital transformation initiatives. I have done my post-graduation from IMT Ghaziabad with an international term in EM Normandy, France. My computer science degree is from Nirma University, Ahmedabad. Today, Himanshu and I will be sharing our experiences on working with various blockchain platforms and in particular about how to deploy a private Hyperledger Fabric network on AWS. We'll be walking you through our code for business applications and also the live demo. Over to you, Himanshu.
Hello everyone, this is Himanshu Malviya, currently working as a blockchain developer in the Digital Innovation Lab at JK Technosoft. Prior to this, I did my graduation from IIT Roorkee. Apart from being a full-stack developer, I have been fiddling with emerging blockchain technologies and exploring their applicability and their integration with traditional systems. Over the next 30 minutes, we will be sharing our learnings, roadblocks, and our solutions for the same.
Himanshu, before we begin, some housekeeping. There is a question and answer window on the top right-hand corner of your WebEx chat screen. In that, you can share whatever questions you have. You can type in and our coordinator will pass them on to us. We'll be taking the questions at the end. So between Himanshu and me, we'll be presenting for around 30 minutes, followed by a 15 minutes question and answer session. So without further ado, let's get the ball rolling. Over to you, Himanshu.
So basically, blockchain is a data structure made of blocks, where each of them is connected to the previous block via a cryptographic hash. Data is appended to blocks as transactions. Once added to a block and validated by the network, data is immutable. Also, blockchain via various consensus mechanisms has the trust built into the system without the need to rely on third-party intermediaries. On your screen, as you can see, there are 4 most omnipresent features of any blockchain framework. Let's begin with shared ledger. This is the core of any blockchain framework wherein the data is stored in a ledger, exact copies of which are maintained at every node. There is no single source of truth, and much of the challenges and benefits are derived from this aspect of same data being maintained at different locations. Next we come across is the term smart contract. This is synonymous with chain code in Hyperledger Fabric, which is nothing but a codification of business-specific logic. Then comes the consensus and cryptography. They are basically the tools that make the whole blockchain framework to work as promised, imparting it immutability and network consistency.
That's very interesting to know, Himanshu. Enterprises have been aggressively exploring use cases to implement blockchain for reducing friction in their business networks in order to scale efficiently. At the recently held event at Davos, a World Economic Forum survey suggested that 10% of global GDP will be stored on blockchain by 2027. That's quite a mouthful. Past 2 years alone have seen more than 500,000 new publications and 3.7 million Google search results for blockchain. Even venture capitalists are abuzz about this technology and have invested $1 billion in 2017 alone in startups. While all these facts are promising, the major challenge businesses are encountering in implementing blockchain solutions is in identifying its strategic value. It's difficult to calculate precisely the potential impact that blockchain can make to your business. And that's where McKinsey & Co. conducted an analysis that revealed key insights about the strategic value of blockchain. According to this survey, blockchain does not have to be a disintermediator to generate value, a fact that encourages permission commercial applications. Blockchain short-term value will be predominantly in reducing cost and in long term, it can transform the business models altogether. Primarily, the main roadblock that blockchain faces is the difficulty of resolving the co-optation paradox. So having known this, it is clear that business leaders need to gain a thorough understanding of blockchain as a technology has to offer in order to gain meaningful value out of it. So let's look through some of the business benefits that blockchain can bring into you. First is reduction in KYC cost. We can easily get secure identity, compile documentation on customer and stakeholder. It is a costly and time-consuming process. We can easily do this using a blockchain technology to efficiently and quickly get the data that is required. As we have all seen and known and heard about, technologies like Ripple, which have been making interbank transactions and international remittances efficient and quicker, that is where our second benefit comes into picture. Also, the risk of fraud and identity theft can be a lesson because there is no central repository where the entire database is stored. So it is difficult to hack. For example, theft of millions of customers of personal data have happened in past at Yahoo, JP Morgan, and LinkedIn. On blockchain, data is encrypted and it's immutable, guarding it a safety with cryptographic encryption. Various tasks can be automated, as Himanshu was mentioning about smart contracts and chain codes. To automate when certain criteria are met, you can automate the tasks. Third is the last one is better pricing. Obviously, it is easier to build distributed and scalable systems on blockchain that can influence the risk, and thus pricing can be almost constantly adjusted and optimized. According to Goldman Sachs, the blockchain technology in banking could save the industry anywhere between $3 billion to $5 billion. Over to you, Himanshu.
Alright, Akash, now that our audience understands the strategic importance of blockchain, let's talk about various blockchain platforms available. A cursory search yields a plethora of blockchain development frameworks. Each of these have their applicability, and depending on the use case, suitable blockchain can be selected.
Himanshu, from our experience, I know of 4 popular blockchain platforms that support implementation of business logics: Ethereum, Hyperledger, Multichain, and R3 Corda. For designing any distributed system, 3 concepts are key. The first is transaction rule. If any participant can directly change the database, how do we ensure that they follow application's rule? What stops one user from correcting the databases in a self-serving way? In this, there are 2 important models: input, output, and contract messaging. These 4 platforms implement them in various ways. The second important property is of determinism. Once these transaction rules have been defined, they will be applied multiple times by multiple nodes when processing transactions for their own copy of database. How do we ensure that every node obtains exactly the same result? Here also there are 3 popular models that are familiar blockchain platforms use. One is endorsement, other is adapted runtime, and third is the purpose-built virtual machine. Next is conflict prevention. With no central coordination, how do we deal with 2 transactions that each follow the application's rule but nonetheless conflict with each other? Conflicts can stem from a deliberate attempt to game the system, or it can be an innocent mistake. Himanshu, this all seems quite complex. Can you help our audience understand how does a business select which blockchain platform is best suited for their application?
Certainly, Akash. While at the core, all are distributed ledgers, but each comes with its own merits and drawbacks. Let's pick up Hyperledger for instance. While it does not inherently comes with the proof of work consensus, but that can be a boon in closed business networks, where all participants are trusted. Similarly, it implements channels, which is a blockchain channel partitioning system. On the other side, it does not have a token in its core, which renders it less favorable mass audience application. but more favorable for a B2B model. Similarly, Quorum is an Ethereum-based distributed ledger protocol that has been deployed to provide the financial service industry with a permissioned implementation of Ethereum that supports transaction and contract privacy. Quorum consists of multiple voting-based consensus mechanism, which in particular to our business case is not required.
Interesting, Himanshu. I think our audience will be able to put this in perspective via the case study we have to discuss. One of the retail giants approached JK Technosoft with the problem that they were not able to effectively track the delays that were happening in the distribution network. They were implementing a traditional hub and spoke model, as you can see on your screen. The retail outlet used to generate or raise an order which was forwarded to the central hub, which would then identify the best suited spoke to fulfill that particular order. In this, there were delays happening that when the management tried to probe and identify, there was no concrete root cause that they were able to pinpoint. Now, when this problem was stated to Technosoft, we easily identified this to be a very good use case for blockchain, because blockchain for supply chain has been quite popular in the market. The advantages of building this system, immediate advantages that we saw was one, that we'll not have to replace the existing system. We designed our architecture in a way that would complement the existing system, and using API hooks, it can easily fetch and post data from the existing system and record it on a blockchain. Let me just walk you through what we did. As you can see on the screen, for each of the corresponding node, we have built an AWS EC2 Hyperledger Fabric node. So whenever any action or trigger happens on the ERP system of these nodes, the concurrent request is being recorded on Hyperledger Fabric network along with a timestamp entry. So for a particular order, the entire timestamp history right from the order generation to the order fulfillment is available at a click of a button. So it becomes very easy for the management to track and see what amount of time is being spent. And this is how we were able to resolve this problem. Himanshu, can you walk our audience through the technical implementation of this particular problem?
All right, Akash. Without further ado, let me introduce us to the technology stack. Thereafter, we'll walk you through the deployment and coding components. We have Hyperledger Fabric version 1.2, Hyperledger Composer 20.5, Sencha EXT.js for user interface deployment. Based on the minimum requirement for a Hyperledger Composer installation, a T2 medium was selected, and for the user interface, a T2 micro was used. Even AngularJS or any other front-end technology can be used. Now moving forward to the deployment steps. Depending on the use case, we deploy nodes. For each node, we have an orderer. And for each organization, we have a certificate authority. An instance of CouchDB or LevelDB, that is databases, is also deployed for each organization. All the nodes are deployed inside separate Docker containers. The next step is to build a connection profile, which basically involves creating the network and making nodes knowing the address of the other nodes. Once the connection profile is ready, the authentication is handled by generating the certificates using the cryptogen tool and providing address of the keys in the connection profile. Once the network is up and ready, then using the certificate generated, a business network card is generated for the administrator to interact with and manage the network. A business network card contains all the information required to connect to a blockchain business network and the underlying Hyperledger Fabric network. This information includes the connection profile created in step 2 and the certificate and private key for the administrator located in step 3, as you can see on your screens. Once the card is generated, it can be used to install and start or upgrade a business network archive into the Fabric network. Thereafter, we proceed to installing of our business network. Now, before proceeding further, let's pause here for a moment and look at this step in more detail. Before installing the Hyperledger Composer business network, we need to create our business network and package it into a business network archive. Let's now walk through the business network created for our use case. As you can see on your screen, there is a model file. This model file consists of assets, participants, transactions. In this skeleton, there is a model file which will contain the class definition of all assets, participants, and transaction in the business network. Now, the asset order along with the participant grocery store and transaction name create order are defined over here. While emitting events helps us to interact with any other existing system, it is basically a web server through which any system can connect to. Next we come across is the script file where our transactions are written. The transaction processor function file contains the JavaScript logic to execute the transactions defined in the model file. Here, create order transaction is intended to simply create the order with its detail and capture the timestamp of the creation of the order. Moving forward, we have the access control rules, wherein we define whether a participant will have read or write or create access. Now that we have the business network ready, we make the BNF file using the Hyperledger composer command line. Let's get back to the deployment of this BNF network. Once we have our business network archive installed on all the peers, the network can be started using composer command line using the business network card. This completes the deployment. Hereafter, we need to create at least one participant who will act as a network administrator. This participant is responsible for onboarding other participants into the blockchain business network. The REST server and web server can be deployed using a particular business network card, which can be a card for specific identity of a participant. So we can apply access control rules at REST server level itself. Now we have the REST server and web server up and running. We can build the UI using the APIs available. Now let's take a look at this video and understand how blockchain can maintain transparency in keeping the track of order in our use case. Here we are initially logging in as grocery store, where grocery store lists the items required and create an order and send it over to the central hub. Now as soon as the order is created, it will be sent to central hub to allocate a warehouse to prepare the order. And after allocating warehouse to the order, the particular warehouse will receive the order and post the preparation will dispatch the order to the requested grocery store. On the below logs screen, you can also see how the logs are coming. They are the results of the transaction that are executed. That concludes the demo. I would now leave the table to Akash.
Thank you, Himanshu. I think that was quite insightful. So just to sum up for our audiences, before we discuss the key takeaways, I would request that if you have any questions, please share it with us. We'll be shortly beginning our question and answer session. During this webinar, we have essentially captured what blockchain is, what strategic value it brings in for your business. Essentially, we identified that cost reduction, and later on long-term basis, it can help transform your business models. We walked through the comparison of various blockchain platforms using the parameter of designing a distributed system like transaction rules, determinism, and conflict prevention. We talked about flavors of Ethereum like Quorum. We talked about Hyperledger. Then we also discussed in depth about the steps of shaping up Hyperledger Fabric network and deploying it on AWS for solving a real-life problem. These are the key takeaways for our webinar today. Before we begin our question and answer session, I would just like to add how JKT helps drive our clients' success, which in turn generates revenue generating opportunity for us. We believe in a TCO year on year by enabling customers to pay less for more. The various services that we at JKT offer cover digital. Under digital, we expertise in technologies like blockchain and artificial intelligence. Today we discussed about blockchain. Tomorrow we have another webinar which will be on artificial intelligence powered chatbots. Alright Himanshu, I think we have our first question coming in from the audience. The participant wants to know that how can we decide which blockchain platform to use? I think that's an interesting question, and it's at the very core or heart of the problem that needs to be solved. We in the development community always say that once you identify the correct blockchain platform to implement, you have won half the battle. So let's try and understand what a software architect or a blockchain architect would be looking at while discussing or deciding which platform to use. So for classification and comparison of blockchain networks, three things are essential. One is the decentralization level. Second is the storage and computation. And third are the various configuration options available to us. Let's look at each of these one by one. So first let's discuss about decentralization. So Himanshu, when we talk about decentralization, we are essentially dealing with two things. One is the level of permission, and second is how do we verify transactions or the external data that is coming in. So when we talk about permission, it varies, the degree varies from a fully centralized system to a public blockchain network like a Bitcoin or an Ethereum public network. How these flavors vary is in terms of the permissions of who can join, who can mine, and who can initiate transactions on the blockchain network. So depending on the use case in question, you need to apply sound logic and decide what level of access control or what level of permissions you need to expose to the world. And depending on that, you decide on the level of centralization required in the system. There will be obvious trade-offs. A public blockchain network would have all the properties that are promised by blockchain and advertised by blockchain platforms, but it would at the same time be less secure in terms of data. I would not use the word secure, I would say less private in terms of your data. And it would also incur more cost because you will be running a proof of work type of consensus mechanism in order to validate your transactions. Versus a centralized network will be cost effective but will not be delivering all the promised properties of blockchain. Second parameter in this is verification rule. Why this is important is that by default execution environment of blockchain is designed to be self-contained. Blockchain cannot directly interact with data from outside world. We need something called oracles to work in between and pass on the data and approve that data so that it can be securely embedded into our blockchain. So here there are various mechanisms that are being implemented. There is a concept of single verifier where the blockchain network, when it is initiated, it decides that this particular node will act as verifier. So whatever data is passed on through that particular node is stored. Then there is also a concept of M of N verifiers, wherein there are N verifiers appointed, and of that at least M should approve that particular transaction. And there can also be an ad hoc model. So having dealt with decentralization, the next thing we step onto or jump onto is the problem of deciding what needs to be stored on the blockchain and what needs to be stored off the blockchain, and what level of computation or business logics are required into your network. So first is, say for example, let's take, how do we come up here is, essentially in this parameter for storage, we need to essentially deal about cost. That what's the cost of storing a byte onto blockchain network, and based on that and how much critical that data's availability on blockchain is. So in that case, let's talk about Ethereum in particular. Let's take one example. As we all know that by default Ethereum charges us 21,000 gas to initiate one transaction. And the cost of storing one non-zero byte onto appended as within the transaction is 68 gas. So if we were to store somewhere around 800 bytes of data on Ethereum within the transaction, we would be incurring a cost of around 0.7 cents US dollar, in terms of US dollars I'm talking about. Versus there is another option on Ethereum for storing data, that is via smart contracts, and in that there are 32 bytes variable available to us, and using SS store operation we can store them by spending 20,000 gas. So essentially here you will have to spend 21,000 gas for transaction and 20,000 for storing 32 bytes. So ultimately if it is just a limited amount of data, this storing via smart contract would turn out to be expensive. Next comes the what you can say, how much computation is required. Say for example, traditional blockchain platforms like that pioneered the concept of blockchain, Bitcoin, only allows you to perform certain conditional checks in order to verify the unspent transaction. Whereas Ethereum has a complete Turing compliant model that via which you can build smart contracts and deploy using language like Solidity and implement more complex business processes and automate certain tasks. So this is what you will need to consider. And towards the end, obviously there will be certain blockchain configuration options, like which consensus mechanism is supported by a particular blockchain platform. As Himanshu was rightly mentioning in the beginning, that Hyperledger Fabric does not implement proof of work, which is advantageous in centralized system because it has been designed for semi-central kind of environment against a public blockchain network. Then how would a new block be mined, or how would a new blockchain transaction or a block be added to the blockchain is another parameter that we need to consider. So, this is a really complex problem, and I would advise that before you jump on and decide on which particular network you want to use, always include someone who has a blockchain architecture level of experience that can help you assess, in particular, in context of your business application, what application is best suited. There is no straightforward answer to this question. I hope I answered to the participant that had this question. While we wait for the second question, Himanshu, do you have any other points that you want to add here?
Yeah, if we talk particularly about our business case, I would like to point out few points. Like, firstly, the broad need was to maintain a consistent, immutable, widely available source of truth. And moreover, in order to capture the delays, we need a fail-safe way to capture the timestamps. So the second requirement which we felt for our use case was the need for different visibility to different participants in the network. These are the access control rules that we have written. And the third requirement that we felt for our use case was the ability for our solution to hook with the existing system seamlessly. So altogether, I think this might sums up all the questions we have. Let's see what next question we have from our participants. So we have, let's say you need to modify business logic. How do we proceed about that? Okay, this question might have popped up to many of our participants because business logic keeps on changing from time to time. So the composer provides functionality to upgrade the network without stopping the network. So you do not need to worry about whether if you want to upgrade your BNA file and the network would stop. All you have to do is modify your logic, repackage our BNA file with a higher version, and using the composer command line, we can upgrade the network. So this sums up the answer, I guess. Let's see if we have our next question.
I think, yeah, Himanshu, we are also having a question about AWS managed blockchain. People are asking how different it is from hosting your own blockchain network on AWS. I think, this AWS managed blockchain has been a very paradoxical scenario wherein, the CEO of a small trivia before we answer this question, that the CEO of AWS mentioned a year before that they are never going to launch the blockchain solution. And a year after that, they have also realized that blockchain is going to be the next big thing. And if as a cloud platform, they are not having blockchain as a service, they'll miss out on that opportunity. So how AWS managed blockchain essentially helps you is that while Himanshu was walking through the code, he mentioned that, we need to set up the business network. We need to configure various nodes and interconnect them using various codes that are required. Blockchain beg your pardon, AWS encapsulates this particular problem, wherein you, by a click of few buttons, you can launch an entire business network and nodes within that. So interconnection of nodes and handling the network level details of security and everything is being managed by AWS. So this is how it helps, how AWS managed blockchain helps. They offer two flavors as of now of blockchain. Hyperledger is one of them, which is already live, and you can start experimenting and running sandbox applications on that. Apart from that, you have Ethereum, which will be launched shortly. Anything you would like to add, Himanshu?
Yeah, sure. If by any chance any of our participants have looked upon the Hyperledger Composer playground, that's similar to Hyperledger Fab, the AWS managed blockchain. So basically what it does is they provide you everything deployed. You just need to go there and type in your business logic and play around. That's similar to your Hyperledger managed blockchain. Sorry, AWS managed blockchain.
All right. Thank you, Himanshu. I think we have our fourth question. It's on about various methods employed for verifying a valid transaction. And the participant wants to know if there is any possibility of majority attack in Hyperledger. This is a very important question in terms of transaction validity. And that's where it's what you can say, I would, to answer it in a word, it is inherent into blockchain network of how to validate transaction. And it depends on what sort of blockchain network you are running. If it is a public blockchain network, then you would essentially be employing a consensus mechanism like proof of work, wherein, while mining those blocks, transactions would be appended and validated. So the miner who would solve that cryptographic hash puzzle that has been part of the proof of work challenge will be able to say that this particular for that particular transaction, the hash that is valid, that transaction will be added to the blockchain. And this once approved by majority of the miners. So in terms of blockchain, we say that before Bitcoin, we say that before any transaction is valid, at least 6 miners need to approve that particular transaction. So 6 miner needs to mine that transaction and verify the cryptographic hash, solve the mathematical puzzle and identify the correct hash and declare that the transaction is valid. So by this mechanism, in terms of public blockchain network, it is validated. In terms of centralized private networks, there are various mechanisms again. One is proof of stake is another popular mechanism that is implemented for validating a transaction, wherein we predetermine who would be responsible, which node would be responsible for authorizing those transactions and validating them. And a stake is given to them, and it is their responsibility to make sure that the transactions are valid. The second question is interesting because in the general media that we see, blockchain and majority attacks have been the popular trend that has been going on, wherein we often now hear about various blockchain platforms. I would not say platform, but the companies that are running blockchain platforms, the front end part is being hacked or is being attacked, and there have been problems with that. But in terms of Hyperledger implementation, I would say that Hyperledger is built essentially for trusted or semi-trusted parties to come into picture and form a business network. So yes, there is a possibility of what you can say majority attack, if that is what your question is. But Hyperledger believes that since the nodes are already trusted in the network, such sort of scenario would not arise versus Ethereum or Bitcoin public blockchain networks that are present. I hope I answered that question. Anything that you would like to add, Himanshu, to this one?
Yeah, on the first part, the methods of verifying a valid transaction, actually, Previously I mentioned about the deploying of REST server and web server using a business network card. So we can allocate a card to a particular identity of a participant. Basically what identity of a participant is, let's say in our business case we had grocery store. So there can be a lot of grocery stores named 1, 2, 3, 4. So if we talk about identity, then identity means a particular grocery store named or the ID equals to 1. So we can deploy the REST server and the web server using the particular card, and we need not to worry about whether they can do transactions of other participants in our business case. So this way also we can verify whether the valid transactions are there or not.
And just to add here, Himanshu, for our audiences who are not familiar with the term majority attack, I think let me simplify it for you. So in public blockchain networks, it is said that there is trust built into the system, and no one can maliciously mangle with the data that is present there. But there is also a catch in that if, say for example, you have enough computation power, the threshold limit in some blockchain networks is 51% stake. If you have power more than 51%, then you can rewrite the entire blockchain as it suits you, and thereby, what you can say, if it is a cryptocurrency network, then you would either obtain all the cryptocurrency coins that are being mined till date and transfer it to your particular address, and thus you will have in possession of all the bitcoins. Or if there is a disagreement and you have the majority, there would be a blockchain fork, as we have observed in case of Bitcoin Cash, or in Ethereum was one of the classic examples wherein there was a major divide between how the transactions should be handled, and we saw that there is still the legacy Ethereum network also runs, and the new coin that is also in process. So the majority attack is the concept wherein we say that if you have a power of more than 51%, you can mangle the data that is present on blockchain, essentially overriding the basic property that blockchain has to offer of a trustless decentralized, trustful network. So that's essentially more about it. I see that we don't have any other questions in pipeline. So with this, we would like to thank to all our participants present in this webinar today. It has been a pleasure interacting with you. You can always write to us in case if you have questions that we were not able to cover here at the email address mentioned on the slide on marketing@jktech.com. Thank you very much. It has been a pleasure. See you all again. Thank you.